Solutions to the third part of the Module 1 Lesson 3 review assignment. So once again, here's a quick view of the template for all transformations, which I talked about in the first part of this lesson, the video lesson, or video solution to the first part of the Lesson 3 solution. If you want to take a quick, pause the video and review this, go ahead. So here we go. We've got this time a specific function for f of x. F of x equals 6 to the x, and we want to create g of x, which is a transformation of that parent function. Looks like we want to do 4 things here. We want to vertically stretch by a factor of 5. We want to reflect over the x-axis. We want to translate 3 units right and 6 units up. So let's start with, we've got values then of a, h, and k, right? So we'll go ahead and start with all of those values in our template, and we'll plug in specifics. So f of g of x equals a times f of x minus h. We don't need the b this time, right? Because there's no horizontal stretches or compressions or reflections over the y-axis. Tell you what I'll do though. Let me just start with that and we'll delete it. So we've got values of a, h, and k. So we can just go ahead and delete that stuff. So that puts us there. All right, so what about a? We're going to vertically stretch by a factor of 5. So that becomes a 5. We're going to reflect over the x-axis, which means a is going to be negative. We're going to multiply the whole function by -1. Multiplying by -1 and 5 means -5. We're going to translate 3 units to the right. That means h is +3 because that's the positive x direction. So I'll replace the h with +3. And 6 units up means k is +6. So that is our answer. Oops, no, it's not though. It's 6 to the x. Our function is 6 to the x. So I'm going to replace f of x minus 3 with the quantity, with 6 to that quantity, right? Because the function is 6 to the x. F of x is 6 to the x. So f of x minus 3 is going to be 6 to the x minus 3. Okay, in this case, we're going to do, let's see, 1, 2, 4 things also. We're going to horizontally compress f of x by a factor of 1/8, reflect over the y-axis, translate right by 1, and translate up by 7. So again, let's just start with our template. Okay, so there's our template. Let's see what we've got. If we're horizontally compressing by a factor of 1/8, then that means that b is going to be that b is equal to 1/8. In other words, we're going to multiply x minus h by the reciprocal of that number. So we're going to multiply by the reciprocal of b, which is 8. We're going to reflect over the y-axis, which means that we're going to multiply the quantity x minus h by -1. Or in other words, the reciprocal of b is going to be negative. We're going to translate right by 1. That's in the positive direction, so h is +1. And we're going to go up by 7, so k is +7. We don't even use the a, so we can get rid of that. A is equal to 1 then. We haven't done anything in terms of vertical stretching or reflecting. There it is. Now we're going to take a specific function and we're going to vertically compress by a factor of 1/4. So that just means we're going to multiply 4 to the x by 1/4. This time we've got the same function, 4 to the x. We're going to vertically stretch by a factor of 2 and reflect over the x-axis. So that means we're going to multiply 4 to the x by 2 to stretch it vertically, and by -1 to reflect it over the x-axis, and so we end up with that. The 10th root of x is our function. We're going to horizontally stretch by a factor of 7, and so that means we're going to multiply. That's all we're doing is horizontally stretching. There's no horizontal translation, so we're just going to multiply x by the reciprocal of 7. So we've got the 10th root of 1/7 x. Function 6 to the x, we're going to horizontally compress by a factor of 1/2 and reflect over the y-axis, but there's no translation going on, so there are no h's and k's. Let me show you that in terms of the template real quick. So okay. So h is 0 and k is 0 because I'm doing no translations of any kind. So I can get rid of that, and I can get rid of the h. Well, look, that just puts x by itself in parentheses, which is unnecessary. So I'll just make that an x. There are no vertical stretches or compressions, and there are no reflections over the x-axis. So A, it has no value other than 1, and it's not negative. What about this, though? So we're left with our reciprocal of B. So if we're going to horizontally compress by a factor of 1/2, then we're going to multiply by the reciprocal of 1/2. So the reciprocal of B takes a value of 2, and that needs to be negative. Whoops, I forgot. I just got to get that B out of there. And it has to be negative because we're also reflecting over the y-axis. Oh, what'd I do? Oh, you know what? I bet you I can't. Oh yeah, I can't. It's f of x that uses parentheses. My fault. Let's make those parentheses instead. And now that should be right. Oh, what did I? Oh, shoot. Dumb me. F of x is specific. It's 6 to the x. It's not just f of x. So what do I have to do here? I have to replace f of -2x with what the corresponding value of f of x would be. If f of x is 6 to the x, that's my pattern. Whatever I input is becoming the exponent, right? So then this would become 6 to the -2x. So I'll just cut that and write 6 to the power of -2x. And that's what we wanted, finally. Okay, this time we're taking the function 6 to the x, and we're doing a couple things. We're going to compress vertically by a factor of 1/5, so that's A, that goes out front. We're going to reflect it over the x-axis, so that means A is negative. We'll multiply the whole thing by -1, and we're going to translate 4 units down. That's K, right? So then we'll end up with -1/5 times f of x, which is 6 to the x, and then tacking on the end would be our k. We're going to go down 4, so we'll subtract 4. And then finally here we've got an eighth root of x. We want to do a couple things. We want to vertically stretch by a factor of 3, translate over the y-axis, translate right and down. So let's go ahead and do this one. We'll start with the template. So a times f of the quantity 1 over b times the quantity x minus h plus k. All right, so what do we got? If we're going to vertically stretch by 3, then that means that a is equal to 3. We're going to reflect over the y-axis, which means that 1 over b, the reciprocal of b, is negative. We're translating 2 units right, so h is positive 2. And we're going 4 units down, so k is negative 4. Okay, but remember, our function f of x is actually the eighth root of x. So whatever we're inputting into the function needs to go inside the eighth root. So I'll just cut that and paste it into the inside of the eighth root. And that should be my answer. And there it is.